In the higher course, we'll be studying 3 types of force fields: gravitational fields, electric fields, and magnetic fields. We'll start with the gravitational field, the one you're probably most familiar with. A field is simply a space, right? A volume, if we're being precise, where a force is experienced. So for example, the gravitational field around the Earth is the space around the Earth where a force is experienced by objects with mass. So we've been quite familiar with this idea from our work in previous courses in Nat 5. And so the gravitational field strength is defined as the force per unit of mass. So G equals F over M. F is the force, the gravitational force, or as we normally call it, W for weight. So the equation is really G equals W over M, or rearranging it, W equals mg. Gravitational field strength is a vector quantity in the same way that weight is a vector quantity as a direction. Both of them have the same direction. And for masses near a planet, the direction of G is always towards the centre of the planet. If we let an object fall freely, then its acceleration will be measured as F over m, which is equal to W over m because the force is W. So substituting in W equals mg and cancelling out the m's, you get that the acceleration is equal to g, i.e. the acceleration due to gravity is equal to the gravitational field strength. If we look at that on the moon, we can actually see, in the absence of air resistance, a feather and a hammer both falling at the same rate, which would be 1.6 meters per second squared on the moon. So we can actually time that quite precisely, use that to get the gravitational field strength is about 1.66 newtons per kilogram on the moon. And the surface of value of gravitational field strength is different for different planets. You're not expected to memorise it. It's given to you in exams.